Good day everyone, here's our math challenge for today. And here's our question. Given that A and B are real numbers between 0 and 1 exclusive, then solve the following system of equation. So we have 1 minus square root of 1 minus a squared all over a plus 2b all over 1 plus square root of 1 minus b squared plus b equals 1, and 25 multiplied by the quantity 1 minus b squared equals 41 minus 40 multiplied by 1 minus a squared. This is the most difficult system of equation I ever encountered. So, without further ado, let's have our solution. Now, how are we going to answer this crazy system of equation? Now, let's have our first equation. So, we have 1 minus square root of 1 minus a squared all over a plus 2b all over 1 plus square root of 1 minus b squared plus b equals 1. Now notice that we have square root of 1 minus a squared and square root of 1 minus b squared. Now on integral calculus, if we have square root of 1 minus x squared, we normally use trigonometric substitution. So, this tells us that maybe we should try to use trigonometric substitution. So, let A be equal to sine x and B equals sine y. Why is that? Because we know already that A and B are real numbers. And A and B are between 0 and 1 exclusive. So, if we let the value of angle x and angle y between 0 and 90 degrees, we don't have any problem, because the value of sine x and sine y is between 0 and 1 exclusive. So keep in mind that the values of x and y are between 0 and 90 degrees. Now let's move on. Let's replace all a with sine of x. So we have square root of 1 minus sine squared x all over sine x. In this solution, we will use a lot of trigonometric identities. And here's the first one. We have sine squared theta plus cosine squared theta equals 1. It follows that 1 minus sine squared x equals cosine squared x. So if we subtract sine squared theta on both sides, we have cosine squared theta equals 1 minus sine squared theta. And now, notice that square root of cosine squared x is the same thing as cosine of x. Thus, this term simplifies nicely. Now, let b equals sine of y. So, this term becomes 2 times sine of y all over 1 plus square root of 1 minus sine squared y plus sine of y. Now, 1 minus sine squared y is equal to cosine squared of y. And square root of cosine squared y is the same thing as cosine of y. Now at this point, we will use again another trigonometric identity. So if we have tangent of theta over 2, it is equal to 1 minus cosine theta all over sine of theta. And here we go, 1 minus cosine x all over sine x. Or tangent of theta over 2 is also equivalent to sine theta all over 1 plus cosine of theta. Thus, 1 minus cosine x over sine x is equivalent to tangent of x over 2. Now, how do we simplify 2 sine of y all over 1 plus cosine y plus sine of y? Now, here's the thing. There's a 1 in the right-hand side. So, what will happen if we subtract 2 sine y all over 1 plus cosine y plus sine y on both sides? So, we have 1 minus 2 sine y all over 1 plus cosine y plus sine y. Now, take note that 1 can be written as 1 plus cosine y plus sine y all over 1 plus cosine y plus sine y. And now, they have the same denominator, so we can combine them. If we do that, we get 1 plus cosine y plus sine y minus 2 sine y all over 1 plus cosine y plus sine y. And on the numerator, sine y minus 2 sine y will give us negative sine y. Now, this is interesting because if we divide the numerator and the denominator by 1 plus cosine y, and we separate 1 plus cosine y to sine y, we get 1 plus cosine y all over 1 plus cosine y. And we know this term on the numerator and the denominator is simply equal to 1. Now, we have 1 minus sine y all over 1 plus cosine y. Take note that it is equivalent to tangent of theta over 2, because tangent of theta over 2 is the same thing as sine of theta all over 1 plus cosine of theta. Therefore, the right-hand side of our equation is equivalent to 1 minus tangent of y over 2 all over 1 plus tangent of y over 2. Now at this point, we will use the third trigonometric identities that we need to use to solve this system of equation. So we have tangent of alpha minus beta equals tangent of alpha minus tangent of beta all over 1 plus tangent of alpha times tangent of beta. Using this identity, we can show that the right-hand side of our equation is equivalent to tangent of 45 minus y over 2. Why is that? Now, using this identity, so we have tangent of 45 degrees minus tangent of y over 2 all over 1 plus tangent of 45 degrees times tangent of y over 2. Now, take note that tangent of 45 degrees is equivalent to 1. Thus, tangent of 45 minus y over 2 is the same thing as 1 minus tangent of y over 2 all over 1 plus tangent of y over 2. And that's exactly the term in the right-hand side of our equation. Thus, we can say that tangent of x over 2 is equal to tangent of 45 degrees minus y over 2. Now, at this point, we can say that x over 2 must be equal to 45 degrees minus y over 2. And don't forget to include a multiples of 180 degrees. Thus, we have x over 2 plus 45 degrees minus y over 2 plus 180 degrees times n, where n is an integer. Now, let's simplify this equation. Add y over 2 on both sides. So, we have x over 2 plus y over 2 equals 45 degrees plus 180 degrees times n. Multiply by 2 on both sides. We get that x plus y equals 90 degrees plus 360 degrees times n. Now, take note that the values of x and y is between 0 and 90 degrees. Therefore, the maximum sum of x plus y must be less than 180 degrees. Therefore, we don't need this 360 degrees times n, because we said earlier that the maximum sum of x and y must be less than 180 degrees. Therefore, this n is just 0. So, we have x plus y equals 90 degrees. Now, this is a good result. Why? Since x and y are complementary, we will use again some identity. Now, we know that b equals sine of y. And using this equation, we know that y is equivalent to 90 degrees minus x. And sine of 90 degrees minus x is the same thing as cosine of x. Thus, we have a equals sine x and b equals cosine of x. Now, at this point, we will use again the first identity that we use. Sine squared theta plus cosine squared theta equals 1. It follows that sine squared x plus cosine squared x equals 1. Thus, a squared plus b squared equals 1. Now, at this point, we are now ready to finish this equation. So, let's take our second equation. We have 25 times 1 minus b squared equals 41 minus 40 multiplied by 1 minus a squared. Using this equation on the bottom, we can say that square root of 1 minus a squared is equivalent to just b. Now, distribute 25. We have 25 minus 25b squared equals 41 minus 40b. Now, equate this to 0. This will give us 25b squared minus 40b plus 16 equals 0. Now, surprisingly, 25b squared minus 40b plus 16 can be factored nicely as 5b minus 4 quantity squared, and it is equal to 0. Thus, we can say that 5b minus 4 equals 0. Add 4 on both sides, so we have 5b equals 4. Divide both sides by 5, we get that b equals 4 over 5. And since we have b equals 4 over 5, and we know that a squared plus b squared equals 1, it directly follows that A must be 3 over 5. Now take note that 3 over 5 and 4 over 5 is between 0 and 1. Therefore, our answer to this crazy system of equation is simply A equals 3 over 5 and B equals 4 over 5. And as always, we are done.